Hello, my name is Ashley Compton, and today I will be discussing Transmission Control Protocol, also known as TCP. What is TCP? TCP, or Transmission Control Protocol, is a standard that defines how to establish and maintain a network conversation through which application programs can exchange data. TCP works with the Internet Protocol, or IP, which defines how computers send packets of data to each other. Together, TCP and IP are the basic rules for defining the Internet. How do TCP and IP differ? TCP and IP are two separate computer network protocols. IP is the part that obtains the address to which data is sent. TCP is responsible for data delivery once that IP address has been found. It's possible to separate them, but there isn't really a point in making a difference between TCP and IP. They are so often recognized together as TCP/IP that it is common terminology. How does it work? TCP is connection-oriented, and a connection between client and server is established before data can be sent. TCP determines how to break application data into packets that networks can deliver. It sends packets to and accepts packets from the network layer. TCP manages flow control, and because it is meant to provide error-free data transmission, it handles retransmission of dropped or misinterpreted packets and acknowledges all packets that arrive. In the Open Systems Interconnection Communication Model, TCP covers parts of Layer 4, the transport layer, and parts of Layer 5, the session layer. When a web server sends an HTML file to a client, it uses the Hypertext Transfer Protocol to do so. The HTTP program layer asks the TCP layer to set up the connection and send the file. The purpose of the layers is to keep things standardized, without numerous hardware and software vendors having to manage communication on their own. It is like driving a car. All the manufacturers agree on where the pedals are, so that's something we can count on between cars. What is TCP used for? TCP is for organizing data in a way that ensures the secure transmission between the server and client. It guarantees the integrity of data sent over the network, regardless of the amount. TCP is therefore used to transmit data from other higher-level protocols that require all transmitted data to arrive. Examples of these protocols include Secure Shell, Simple Mail Transfer Protocol, and HTTP. Why is TCP important? TCP is important because it establishes the rules and standard procedures for the way information is communicated over the Internet. TCP is the foundation for the Internet as it exists today and ensures that data transmission is carried out uniformly regardless of the location, hardware, or software involved. TCP is flexible and highly scalable, meaning new protocols can be introduced to it and it will accommodate for them. It is also non-proprietary, meaning no one person or company owns TCP. 4 layers of TCP IP. Network access layer. A network layer is the lowest layer of the TCP IP model. It defines how the data should be sent physically through the network. Internet layer. The main responsibility of the Internet layer is to send the packets from any network and they arrive at the destination irrespective of the route they take. Transport layer. The transport layer is responsible for the reliability, flow control, and correction of data which is being sent over the network. The 2 protocols used in the transport layer are User Datagram Protocol and Transmission Control Protocol. Application layer. The application layer is responsible for handling high-level protocols, issues of representation. The application layer is the topmost layer in the TCP IP model. Does TCP work with all types of IP address? The differences between types of IP addressing are transparent to a casual user, and the fact that you don't need to know much about it is among TCP's strengths. Usually, these matters are managed by whoever sets up your computer operating systems or mobile device. Static IP addresses stay the same all the time. They are like the fixed address on your home, an unchanging address. Dynamic IP addresses change, or at least they are designed to change. When a computer system uses a dynamic IP address, it announces, "This is where you can find me," to the local network. Rather like the address of a hotel room where the hotel knows how to find you. Advantages of TCP. TCP is an industry standard model that can be effectively deployed in practical networking problems. TCP is an open protocol suite. It is not owned by any particular institute and so can be used by any individual or organization. TCP is a scalable client-server architecture. This allows networks to be added without disrupting the current services. TCP assigns an IP address to each computer on the network, thus making each device to be identifiable over the network. Disadvantages of TCP. TCP is not generic in nature, so it fails to represent any protocol stack other than the TCP suite. For example, it cannot describe the Bluetooth connection. TCP does not clearly separate the concepts of services, interfaces, and protocols. So, it is not suitable to describe new technologies in new networks. TCP doesn't distinguish between the data link and the physical layers, which have very different functionalities. The data link layer should concern with the transmission of frames. A proper model should separate the two layers. TCP was originally designed and implemented for wide area networks. It is not optimized for small networks like LAN and PAN. Thank you.